What is the value of? Well, if you add up all the numbers, it will be, I believe, 36, and therefore the root of 36 is 6. A bucket that is 2/3 full contains 9 liters of maple syrup. What is the capacity of the bucket in liters? So 2/3 of the bucket, which I'll call x, is 9. So this is the algebra. So x is 9 times 3 divided by 2, and therefore x is 13.5 liters, I guess. The sum of 4 consecutive odd integers is 200. What is the largest of these 4 integers? An odd number is of the form 2n plus 1. So if they're consecutive, it would be 2n plus 1, 2n plus 3, 2n plus 5, and 2n plus 7. They're consecutive odd integers, and they're saying the sum, so add them all up, is 200. So I believe that's the algebra for this question. And then when you add this all up, it's 8n plus 16 is 200. And therefore 8n is 184, and n is 23. Now we're not done yet. Don't just write 23 and move on, because they want you to find the largest of the 4 integers. And the largest of the 4 integers was 2n plus 7. So that's what you have to figure out, 2n plus 7. So that would be 2 times 23 plus 7, and that is 53. And this 53 is the answer to the question. It takes 18 doodads to make 5 widgets. It takes 11 widgets to make 4 thingamabobs. How many doodads does it take to make 80 thingamabobs? Well, let's try to keep this in the same page here. So we've got 18, let me think about this. Let me just put letters instead of the whole. So 18 doodads goes to 5 W's, right? Okay. And then it takes 11 widgets. Okay. So 11 widgets. Okay. So if I just multiply both sides by 11 here, this is really should be an equal. I don't know why I put an arrow. I'll just put an equal from now on. Just 11 times W. That's equivalent. Okay, so what do I do next here? This side I'm going to keep 11D, and then this I'm just going to switch the 11 and the 5, because this 11W is 4 thingamabobs, right? So that 11W, I can put 4T, T representing the thingamabobs. And then I think so far everything is equal. And therefore this is 20T. Is 11 times 18D. Now they want 80. So I just have to multiply both sides by 4 to get that to be 80. And then therefore that's 80T. And then this number, if I multiply those, it's 792. So as you can see, in not a very complicated way, I can get the equivalent, that 792 of those doodads are required to make 80 thingamabobs. So 792 is the answer to this question. In the diagram, points P1, P3, P5, P7 are on BA, and points P2, P4, P6, P8 are on BC, such that BP1 is equal to P1, P2 is equal to P2, P3, P3, P4, and so on, all the way down to P7, P8. If angle ABC is 5, what is the measure of angle P7, P8? Let's blow this up a bit, and we have to do angle chasing. Angle chasing. So here we go. So the first thing is we're going to utilize this piece of information, the ABC being 5. So ABC. So this angle in here is 5. Let's see if I can squeeze that in there. I'm not able to squeeze it in, so I'll just write it here. Okay, that's 5. And then based on the information they gave me, I think I might use a different color here. This is the same as that in terms of the sides. So that means that this angle in here is also 5 because of the properties of an isosceles triangle, and you guys know all about that. And then similarly, this is the same as that. So if that's 5 and that's 5, then this angle in here, this angle right here is 170, right? So therefore, this angle in here would be 10. And then therefore, that would be 10. And then therefore, this angle in here would be 160. And then you just keep going like that. And then this will be 15, right? Because that's 5, that's 160, that'll be 15. And since this is the same as that, that's going to be 15 there. And then this one would be 150. And then this one would be 20. Because 10, 150, and 20 add up to 180. And very same kind of concept. Those sides are the same, so that's 20 also. And then this angle in here is 140. And then we can easily calculate that that's 25. That's the same as that, so that's 25. And that's 130. That's 30. That's 30. Therefore, this would be 120. That's 35. That's 35. That's 110. And then finally, that's 40. And that 40 is what they were asking for. A polygonal pyramid is a three-dimensional solid. Its base is a regular polygon. Each of the vertices of the polygonal base is connected to a single point called the apex. The sum of the number of edges and the number of vertices of a particular polygonal pyramid is 1915. How many faces does the pyramid have? This question just says polygon. It doesn't give me how many sides, so I have no idea. So let me just start off with a simple example. Let's start off with a hexagon. A hexagon, I believe, has 6 sides, if I'm not mistaken. And let me just draw in the apex the best that I can here. I don't know how well this is going to go, but let's just say that's the apex. And let me just connect it. These are supposed to be straight lines, but you guys get the point. So this top right there is the apex. So let's start counting. Let's see, what do we get? For vertices, for edges, and for faces for the hexagon. Okay, so for vertices, 1, 2, 3, 4, 5, 6, and then the apex, right? So 6 vertices, I believe. Edges, oh boy, edges a little bit more. 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11, 12. Yeah. 1, 2, 3, 4, 5, 6, and then the 6 at the bottom, so 12 there. And then faces would be 6 plus 1, so 7. All right. Now, yeah, okay, I know you think, well, how does that help? Well, so far it doesn't, but let's do it again, but this time with a pentagon. 1, 2, 3, 4, 5. Well, hold on. I don't even know. 1, 2, 3, 4, 5. Yeah, that's a pentagon. And then I've got to draw the edges here. Oh, boy. There we go. Okay, that's not so bad. Okay, so for pentagon, let's do the same kind of thing. And hopefully the point is, or the goal is rather, to get sort of a pattern. They can say, oh, okay, I got it. For this many, it's going to be this many, and that kind of thing. So let's see. So this was hexagon, by the way, is 6 sides. Pentagon, just in case you forgot, is 5. So same thing, vertices, edges, and faces. Okay. For vertices, it's 6. For edges, it's 10. And for faces, it's 6. 5 plus 1, yeah. So, well, hold on. Let me just... boy, oh boy. Sorry about this. This is supposed to be 7. Vertices, 1, 2, 3, 4, 5, 6, 7. I know you guys are probably thinking, why did he put a 6 there? Sorry about that. Okay, so I think you can deduce from this diagram a general formula. And that is, if you have an n-gon, meaning that n represents this number here, the number of sides, the number of vertices will be The number of vertices would be n plus 1. The number of edges would be 2n. And the number of faces would be n plus 1. So what they're saying in this question is the sum of the number of edges, so in that case 2n, plus the number of vertices, which was n plus 1, is 1915. So that means 3n is equal to 1914, and therefore n is 638. And they're asking how many faces. Well, the faces is n plus 1, so n plus 1 is 639. And that, 639, is the answer to this question. There are 4 ways to evaluate the expression plus or minus 2, plus or minus 5. 2 plus 5, 2 minus 5, minus 2 plus 5, and minus 2 minus 5. There are 8 ways to evaluate the expression plus or minus 2 to the power of 11, plus or minus 2 to the power of 5, plus or minus 2 to 2. When these 8 values are listed in decreasing order, what is the third value in the list? Okay. So we got 1, 2, 3, 4, 5, 6, 7, 8. So it's just one of those time-consuming things. You got to put this all. So the biggest one is obviously going to be all the pluses, right? So plus, plus, plus. And then, let me think about this. Then only one negative would be these guys. 2 negatives would be these guys, and this will be all the negatives. Negative, negative, negative. So this would be negative, negative, plus, negative, plus, negative, plus, negative, negative. And then negative, plus, plus, negative, plus, plus, like that. Now, just to be on the safe side, you can calculate all of them, but I don't think you need to. When you do this guy, this is 2082. So let's do these. So this is minus 2 to the 11, plus 2 to the 5th, and plus 2. This is, oh boy, what is it? Minus 2048 plus 34. So minus 2014, I believe. And then the plus negative plus, plus negative plus, 2 to 11, 2 to the 5, and 2. 218, and the plus plus negative, that's 2 to the 11, 2 to the 5, and 2. And that one is 2078. And these ones are going to be less. So this is obviously the biggest, second biggest, third biggest. So third biggest is 2018. And like I said, if you really want to be on the safe side, you can calculate these guys and see if this one is indeed the third in terms of decreasing order. For how many positive integers n is the sum less than 3129? All right, so you have sum of cubes. Now, 1 plus 2 plus 3 all the way dot 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 till n. You guys know that one, right? The formula n times n plus 1 over 2. Now, there's another formula for sum of squares. So 1 squared plus 2 squared plus 3 squared plus dot 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 all the way till n squared. There's a formula for that. I don't have it memorized, believe it or not. And then there's another formula for sum of cubes. So 1 cube, 2 cube, 3 cube plus dot dot dot. Like so, obviously, this is the sum of cubes. Now, here's the thing. You might say, well, I don't remember what that formula is. So if I don't remember the formula, am I not going to be able to answer this question? And the answer is no. This question is very interesting in that you don't even need these formulas. I just listed them because that's the first thing that went through my mind when I saw this. I thought, oh, okay, sum of cubes. But here's the interesting thing, and I'll do it first with numbers, because if I do it with letters, it might look a little abstract. Let's do it with numbers, and you'll perfectly understand what I'm talking about with numbers. Okay, so let's say you have 0, and let's go till about minus 5, minus 6, and minus 7. Okay, and we are, what am I doing here? I have sort of designated a number, right? I've designated n to be 7. Yeah, so look at this guy here, and what I've done, I've sort of given n a value. Okay, so then this guy right here is minus n cubed, and that's going to be minus 243. This guy is minus n plus 1 cubed, which is minus 6 cubed, and that's going to be minus 216. And then the next one would be minus 5 cubed, which is minus, what is it, 125, I believe, and so on, right? You guys get the point. Now, if you go all the way to the other end of the table, where you have 5, 6, 7, then you're going to get to n cubed, which is this guy, and that's 243, I believe, yeah. And then you're going to have 6 cubed, which is 216. The one before it, 5 cubed, 125. And then they have one extra one, n plus 1 cubed, which is 8 cubed, and whatever that is. So we'll just put 8 cubed for now. Now notice what happens. They're adding them all up. So when you add them all up, they all cancel. This cancels with that. That cancels with this. This cancels with that. Everything will cancel except the very last term. This is the only term left over. See what happened there? So very similarly, this whole thing, this guy cancels with this guy. This one cancels with this one. And so on. Everything from here to here cancels. And you can make the similar number line with n's and you know, see that. So the only thing left over is this one. So that whole expression basically simplifies to just n plus 1 cubed. That's it. So that's why you don't need these formulas. This is a very interesting question, because if you kind of went in this direction, it would I think take a lot longer. But if you recognize that these all cancel, then you know it's just n plus 1 cubed that it's reduced to. And they're telling me that they want that less than 3129. Okay, not a problem. Then take the cube root of both sides, so n plus 1 is going to be about 14.6, and therefore is less than 13.6. And therefore, since n is less than 13.6 and n has to be a positive integer, n can be anything from 1, 2, 3, ... to 13. So there's 13 possible values for n. So therefore, the answer to this question would be 13. For real numbers, a and b, we define a symbol b to be equal to ab minus b a squared. For example, 5 symbol 4 is 5 times 4 minus 4 times 5 squared, which is negative 80. Determine the sum of the values of x for which 2 symbol x minus 8 is equal to 8x symbol 6. So we'll just use that formula, I guess. Nothing fancy here. Just take that formula and apply it to this guy. So 2 symbol x minus 8 is x symbol 6. So here we go. So I believe that's going to be 2x minus x times 2 squared minus 8. And on the other side, it will be x times 6 minus 6x squared. So this is 2x minus 4x minus 8, 6x minus 6x squared. Let's put everything on one side, and let's see what we get. 6x squared minus 8x minus 8 is equal to 0. And I think we divide through by a 2. That will give me the following. Okay, so what do they want here? Determine the sum of the values of x. So basically what they want is the sum of the roots. Now, there's a formula. Some of you know it, some of you don't. It's called Vieta's formula. Very helpful, actually. That states that if you have a quadratic equation of the form ax squared plus bx plus c is 0, the sum of the roots is equal to minus b over a. So in this case, my minus b over a would be, well, this is b, so it would be minus 4. And this is my a, and therefore that is 4 over 3. And that quickly solves the question. Now, if you didn't know Vieta's, you would have to use a quadratic on that, figure out the two roots, and then add them. So that's how you do it without Vieta's. Burgett has a list of 4 numbers. Luciano adds these numbers together 3 at a time and gets the sums 415, 442, 396, and 325. What is the sum of Burgett's 4 numbers? Let's say the sum, the 4 numbers are A, B, C, D. So therefore the sums, the 3 at a time sums would be A plus B plus C, A plus B plus D, A plus C plus D, and B plus C plus D. And those sums would be 415, 442, 396, and 325, according to the question. So they want the sum of all of them. So let's add them all up. So this whole thing, add it all up, and when you do, you get 3a plus 3b plus 3c plus 3d. And this whole side would give me 1578. And then factor out a 3, and we just have a plus b plus c plus d there. And then divide through by 3, and when you do, you get 526 for a plus b plus c plus d. And that is what they wanted. They want the sum of those four numbers, where those were the four numbers. So 526 is the answer. On Monday, Crykor left his house at 8 a.m., drove at a constant speed, and arrived at work at 8:30. Tuesday, he left his house at 8:05, drove at constant speed, and arrived at work at 8:30 a.m. By what percentage did he increase his speed from Monday to Tuesday? Let's see here. So we're going from his house, home, to work. And let's see here. On Monday, he leaves at 8:05. And at Tuesday, Monday he leaves at 8 o'clock, and Tuesday is 8:05. Okay. And then Monday speed I'll call S1, Tuesday speed I'll call S2. And then the arrival times are the same, right? Yeah, the arrival times are the same, 8:30. Okay, so we have two calculations for Monday and then for Tuesday, and we use that formula, speed is equal to distance over time, very famous formula. All right, so for Monday, S1 would be distance over time, and the time in this case is half an hour, because, we can use half an hour, 30 minutes. I usually just convert it to hours. Either way is fine. It's up to you. It doesn't really matter what units used. For Tuesday, S2 would be the same distance, but this time it's not 30 minutes, 25 minutes, so that's 25 over 60. Yeah. Okay. So this basically means that D is equal to 1/2 S1, and this basically means that D is equal to, 25 over 60 is 5 over 12, and that's S2. So there we go. We got this and this, so set them equal to each other. That means 1/2 S1 is 5 over 12 S2, and therefore S1 would be 10 over 12 S2, or 5 over 6 S2. So for example, if S2 was, say, 100, that means S1 would be 5 over 6 times S2, which would be, I believe, 83.3. So they want a comparison of how much faster, right? By what percentage did he increase his speed? So he increased the speed in this case by 16.66, but they want a percentage. So 16.66 divided by 83.3. That is what they want. And that's exactly 20%. If you did it in fractions, it would be exact. Probably better to do it in fractions rather than percentages. Well, 20% is the answer. What is the value of this big long expression? So throughout this expression, we're going to use log rules, and you guys know log rules, and I'm going to assume that you know them all. So the first one, log of the base 218 root 2, you just put that pi up there. And you do the same thing for all the other ones. So 218, and then pi, and then root 2. And same thing. So this will be 218 base again. This one I'm going to put as -1, and then put the pi like that. Just makes it a little bit better. You don't have to do that, but I like doing that. So log, again, the last one, pi -1, all to the pi. Oh, sorry, all to the root 2 this time. Oh, that's a little bit different. Okay, you got to pay attention here. Oh, I think I did that correctly. Okay, so then now we use another log rule to combine them. Why? Because the bases are all the same. So it's all 2018, but then you can combine them. So it'll be root 2 pi times pi to the root 2 times root 2 to the negative pi times pi to the negative root 2. Yeah. Okay, that's pretty good. Let me just see if I did that correctly. Hopefully. Yeah. Okay, so at this point, we just combine them. So the root 2's, you add exponents. So it would be root 2 to the pi minus pi. So that's root 2 to the 0. And then these pi's, again, you add the exponents. So root 2 minus root 2, which is 0. So it would be pi to the 0. Okay, interesting. So that means that's root 2 to the 0 is 1. And then 1 times 1. So that's really just 2018 to the 1. And this is 0. Yeah. I think that's it. So because 2018 is equal to 1. Sorry, is equal to 0. That means 2018 to the power of 0 is 1. Yeah, that works. So interesting. This whole big thing is actually equal to 0. An Euclid number is a 3-digit positive integer with the properties that for some integer k, where k is between 0 and 7 inclusive, its digits are k, k plus 1, k plus 2 in some order, and it is divisible by k plus 3. Determine the number of Euclid numbers. Okay, well, we've got, oh boy, I'm trying to think, where do I start with this? Well, let's start with an example. Let's say k is equal to 0. If k is equal to 0, the digits, therefore, are k, k plus 1 and k plus 2, correct? According to what they have given. So therefore, if k is 0, this would be 0, 1, and 2. And they are saying that you are making a 3-digit number with this. So our combinations would be kind of limited because 0 can't be the first digit because that would no longer make it first a 3-digit. It would be 102, 120, or 201, or 210. Those are the only 4 possibilities when k is 0. So let's just put, k equals 0. We've already put that in. Let's just say put k equals 0 here. And these are the numbers. So these are the integers. And then they're saying that it's divisible by k plus 3. So k plus 3 in this case would be just 3. So we need to figure out how many of these possible integers, so just put possible there, are actually Euclid, whatever the hell it's called, Euclid numbers, by circling them in red. So these possible integers are going to be Euclid numbers if they're divisible by this guy, in this case is 3. And of these 4, I believe all of them are divisible by 3. So I'll circle them. Got it? So I'll put the number Euclid numbers. There's 4 in this case. 1, 2, 3, 4. Okay, so I'll do a couple more and then you guys, I'll just put in the full table. So let's say k is 1. If k is 1, this will be 1 and 2 and 3. The numbers, if k is 1, there's 6 this time because now the first digit can be either 1, 2, or 3. So the numbers are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Now, k plus 3 this time is going to be 4. So these numbers have to be divisible by 4 for it to be an Euclid number. And of those, only 2 are divisible by 4. I will let you figure out which ones. It shouldn't be that hard. Since I'm a nice guy, I'm going to circle them. It's actually not hard because it's the even ones. If a number is divisible by 4, it has to be even. So that's those 2. So this is 2. There's 2 in that. And then I'm going to spare you the pain of going through all of these by inserting the full table which I'm sure you guys can do. And here's the full table right here. So exactly what I did. And that column, this I showed was 4. This was 2. And there's none here. 0. There's 2 here. 1 here. Oh, hold on. Let me see if I'm doing this right. Yeah. When k is 4, there's 1. When k is 5, there's 1. And then 0 and 0. So the total is 4 plus 2 plus 2 plus 1 plus 1. And that is 10. 10 is the answer to this question. An arithmetic sequence has 2036 terms labeled T1 through T2036. Its 2018 term, 2018 term, is 100. Determine the value of T2000 plus 5T2015 plus 5T2021 plus T2036. Okay. Well, if you have T1, T2, T3, T4, and so on, right? All the way till T2018, all the way till T2035, and then finally 2036. It's an arithmetic sequence. So what that means is that this one is A, this is A plus D, this is A plus 2D, this is A plus 3D, and so on. So T2018 would be A plus 2017D. This would be A plus 2034D. And this one would be A plus 2035D. Correct? Okay. So they gave us the value of one of these guys. They told me that this is equal to 100. So that means this A plus 2017D is 100. Now they want me to find this, okay? T2000 plus 5T2015 plus 5T2021 plus T2036. Okay, so let's put it in with all the D's. So this is going to be A plus 1999D plus 5 times A plus 2014D plus 5 times A plus 2020D, right? And then finally, the last guy is A plus 2035D. So let's add all this up. And when you do, I think it's 12A, right? Yeah, 12A. And then all the D's, if you add those up, make sure you multiply first by the 5s whenever it's necessary. And that's going to be 24204D. Now, at this point, you think, well, how does that help? Well, it helps because we know that. And if you can factor out a 12, it gives you A plus 2017D. And that's the magic there, because we know that is 100. So therefore, that's 1200. So a little bit of self-confidence here. Don't get too freaked out by this question. It's actually pretty straightforward. A square wall has side length n meters. Guillaume paints n non-overlapping circular targets on the wall, each with radius 1 meter. Matilde is going to throw a dart at the wall. Her aim is good enough to hit the wall at a single point, but poor enough that the dart will hit a random point on the wall. What is the largest possible value of n so that the probability that Matilde's dart hits a target is at least a half? Let me see if I understand this question. So we've got some sort of a wall, and it's an n by n wall, and then there's these circular targets, whatever. So the area of the wall is n squared, because it's a square. And the area of each of those circles is pi r squared, where the radius is 1. And there's n of them, right? Yeah, there's n of them. So there's n times that. So n pi is the total area of the circular areas. Area circular areas. So the probability is basically the area of the circular areas divided by the total area. I believe that's it. And that's going to be pi over n. That's the probability. And they're saying that we want the probability to be at least a half. So we want this to be at least a half. So we want it to be greater than or equal to a half. And then they want you to figure out the largest possible value of n. Okay? So working with this, that would mean that 2 pi, and then on this side would be n. So n is less than or equal to 2 pi. And pi is 3.14, so that would be 6.28. So n is less than or equal to 6.28. So therefore, the largest value of n would be 6, since n is an integer. And I believe that's it. Determine the largest positive integer n for which 7 to the power of n is a divisor of the integer 200 factorial over 90 factorial times 30 factorial. So we got 200 factorial over 90 factorial over 30 factorial. Okay. Well, this reduces to, well, let me think about this. The 90 factorial will cancel. See, the top is sort of like 90 factorial times 91 times 92 times 93 all the way till 200. But on the bottom we've got 90 factorial times 30 factorial. So these two 90s will go. So all you're really left with is 91 times 92 times 93 all the way till 200 on the top, and on the bottom we have 1 times 2 times 3 all the way till 30. And that's pretty much all there is remaining. Okay, so now this question is really just asking for 7 to the power of n. So really we only care about multiples of 7. So everything else is irrelevant to this question. So I'm just going to write the multiples of 7, which are 91, 98, 105, 112, and so on, all the way till 196. Everything else you kind of just group there in some bracket when we don't even care what it is, because it has no 7 in it, so it's not going to play a role in our question. Same thing with the bottom. We're only interested in the 7, so 7, 14, 21. Actually, 7, 20. There's just 4 of them, so I can list all of them, and then all the other numbers you just group. So this part of the question we kind of don't care about. We just care about this. Now we have to look at how many 7s are we. Now we have to figure out the 7s from each of these. Okay, so from the 91, I believe that's 7 times 13. The 98 is 7 times 14, and so on. 7 times 15 for the next guy, 7 times 16, and then it keeps going all the way till the last one, which would be 7 times 28. And on the bottom, it's just 7 times 1, 7 times 2, 7 times 3, and 7 times 4. Okay, so now it's a little bit tricky for the top. The bottom one is just 7 to the power of 4, and then this other stuff that we don't care about, the 1, 2, 3, 4. So that the bottom is easy, but the top is a little bit tricky, and that's where I think people will make the biggest mistake. They'll say, oh, there's all these 7s, so let's count the 7s. And when you do, you get 16 of those 7s. So they say, okay, well, that's 7 to the power of 16, and we're done. But you're not done, because some of these have 2 7s. For example, this 14 is 7 times 2. So you get another 7 in there. You see that? And similarly, this 28 is 7 times 4. So you get another 7 in there. And there was a 7 times 21, and that 21 is a 7 times 3. So that, if you notice, gives you 1, 2, 3 extra 7s, and that is, I think that's the tricky part of the question. So that means you got to have that 7 to the power of 3 in there. So 7, 16, 3, that's 7, 19, and then minus the 4 to be 7 to the power of 15. And this is the largest divisor of 7 to the power of n. And therefore, what really they're asking for is n, which is 15. So it's a pretty cool question, and you got to be a little bit careful to get those extra 3 7s. In the diagram, D is on a side AC of triangle ABC, so that BD is perpendicular to ACL. So BAC is 60 and BCA is 45. If the area of ABC is 72 plus 72 root 3, what is the length of BD? Okay, well, let's keep in tradition here with the, I think a little bit of angle chasing, not too much though. This is 60, so that's 30. And then, did they give me anything else? BCA, yeah, BCA is 45. Okay, and anything else? Well, this is also 90 degrees, and therefore this is 45. So that means that this side is the same as that side, so I'll just label that X and that X in terms of the side lengths. And then, let's see here, they gave me, did they give me anything else? I think that's it. So the area of the triangle is 1/2 base times height. So the base is A to C, and the height is BD. And they're saying that's 72 plus 72 root 3. Okay. Now, I've got to figure out, I guess the length of BD is what we're trying to figure out. So really what we're trying to find is X in this question, the length of BD. Okay, I got it. Okay, so a couple of these I think I can put in pretty quickly, or at least one, BD. But AC, I'm going to need a little bit more help here. That is where the 30, 60, 90 triangle comes in. So let me just draw it again. So if that's 30 and that's 60, the ratio of the sides are 2, 1, and root 3. That's the ratio. Now I have labeled that side, this one, X. So this side, which I guess is DA, so X over DA is the equivalent of root 3 over 1. So DA is the equivalent of X over root 3. Is that right? Yeah. So that means AC, this whole thing, is AD, which is X over root 3, plus CD, which is X. So this is X plus X over root 3. Okay, so hopefully I've done that properly. And then this side doesn't change for now. Okay, so this basically is the algebra, and I have to now solve for this. Okay. All right, so here we go. So we've got, let's see here. What am I doing here? So we got 1/2, and then to be X squared plus X squared over root 3, right? And let me factor out the X squared, and when I do, I'll get 1 plus 1 over root 3. Yeah, and then let me add the fraction. So it'll be root 3 plus 1 over root 3, X squared over 2. And this side, I think if I factor out a 72, I'll get 1 plus root 3. Okay, so if I put just this X squared and 2 root 3 together, and this is 1 plus root 3, so then that will cancel from both sides. Okay, that makes my life easier. So this cancels with that. So we just get X squared 2 root 3 is 72. So that means X squared is 144 times root 3. So X would be 12. And then the square root of 3. So I guess root 3, the fourth root. Yeah. Interesting. Or you could just write 144 root 3 and then just put a big square root over it. But I think this is probably a little bit better format to write it in. BB, AAA, BA, and all A's are examples of words that are 7 letters long, where each letter is either A or B. How many 7-letter words in which each letter is either A or B do not contain 3 or more A's in a row? Well, we have 7 spots, right? And each spot has 2 choices, either an A or a B. So the total number, you multiply it all together, and that's 2 to the power 7, which is 128. So that's the total possible ways of creating these 7-letter words with these 2 letters A or B. Now what we want is the number that do not contain 3 or more A's. So I think the easier way is to figure out the total and subtract from that the ones that do contain 3 or more A's in a row. If I do that, then I'll get exactly what they're asking for, which is the how many that do not contain. Okay, so let's make a table here. So what do we have here? Do contain 7 or more A's. So 7 or more A's, 3 or more A's would be either 3 A's in a row, 4 A's in a row, 5 A's in a row, 6 A's in a row, or 7 A's in a row. If I count those, then I can solve this. This mathematics, the total is 128, and if I get this total, I'll just put it in there, and then I'll get the final answer. Okay, so 7 A's in a row, I think that's the easiest. That's just A, and there's only one way of doing that. So there's only one of those guys. 6 A's in a row, well, you can have the A's at the beginning and then a B, or you can have the A's as the last 6, like that. So there's 2 ways of doing that. So far that's easy, but now it gets a little bit complicated. 5 A's. Oh boy. I really feel like writing this all out. 5 A's, we got the 5 A's in a row, and then a B, and then an A. Or you can have 5 A's in a row, and then 2 B's. Yeah. And then you can have the sort of the reverse, where you have the A's as the final 5, and then a B, and then an A. And the same kind of thing, where you have the A's as the final 5, and then a B and a B. And then you can have A's in the middle, and then B's on both sides. Yeah. So this is 5. Correct? Yeah. Okay, so 4 A's and 3 A's is what's left. I don't think I have any space here. 4 A's and 3 A's. Okay, you do it. I mean, it's kind of to the point where I can't spoon feed everything here. I'm sure you can do this, right? And I'll just give you the numbers. For 4 A's, it's 12. There's 12 ways. And for 3 A's, it's 27. So you add up all these guys, and you get, let's see here, 39, 40, 47. Right? So 47 goes here, and then 128 minus 47 is 81. So 81 is the answer to this question. Determine all real numbers x for which x to the power of 3/5 minus 4 is equal to 32 minus x to the power of 2/5. X to the power of 3/5 minus 4 is equal to 32 minus x to the power of 2/5. Let's break this up a little bit. So x to the power of 1/5 to the power of 3 minus 4 is equal to 32 minus x to the power of 1/5 to the power of 2. And then what I'm going to do is I'm going to let x to the power of 1/5 equal something. So let's just equal a. So this becomes a to the power of 3 minus 4 is equal to 32 minus a squared. Put everything on one side, and it'll be a to the power of 3 plus a squared is equal to 36. Or actually, I should have put it all on one side. The minus 36 is equal to 0. Yeah. And then this factors. We got a minus 3, a squared plus 4a plus 12. And I'll let you do the quadratic, and when you do that, you'll find there's no real roots here because the discriminant is going to be less than 0. And this, of course, has a root that a equals 3. Okay, we're not done yet because they want x. I created the a. So x to the 1/5 is actually 3. Take the 5th power of everything. Therefore, this will be 3 to the power of 5, and 3 to the power of 5 is 243. So there you go. That's the answer. In ABC triangle, BC is equal to AC minus 1. AC is equal to AB minus 1. Cos of BAC is 3 over 5. Determine the perimeter of triangle ABC. As soon as I see this, this screams cosine law. Cosine law. And those of you who have forgotten it, no problem. I'll just remind you. So if you have a triangle ABC and the sides are labeled A, small b, and small c. Cosine law. Small c squared. I know these look like the same, but I'm really, let me just use a different color. This guy, that guy, squared would be equal to the small a squared plus b squared minus 2ab and the cos of the big guy, this one. That angle is really what they're referring to. So we'll do the same thing, but we'll this time do it with what they have given us. So ABC, it doesn't really matter how you label it. So let's see here. I'm going to call AC, I'm just going to call it X. So BC would be X minus 1. And then AC would be X plus, hold on. AC, what did I do here? AC I'm calling X. BC would be X minus 1. And then AB, if this is X, AB minus 1. AB would be X plus 1. Yeah, got it. Okay. All right, so now that I get that. And then this is, of course, very important. That's going to be utilized. So let's use the cosine law. So X minus 1 squared would be equal to X squared plus X plus 1 squared minus 2 times X plus 1 and the cos of theta. And where's theta in this case? Theta is here, right? That angle in there. All right, so what are we trying to figure out? Oh, the perimeter. So obviously we have to figure out the value of X, and then the perimeter would be X plus 1 plus X minus 1, which is basically 3X. Okay, so obviously I need the value of X. Okay, so here we go. We've got to do that. I'm sure you guys can do it, right? This substitute for this, substitute 3 over 5, and then you're all set. And I'll do a little bit of this, even though I shouldn't. You guys should have to do this, not me. So okay, let's just expand it out. 2x plus 1, blah blah blah, and this is what is this? Minus 2x times x plus 1 over 3 over 5. So 2x times x plus 1 over 3 over 5, and then put everything else on this side. So that goes with that. This becomes x squared. That becomes 4x. And I think that's it, because these cancel. The 1x goes, so this just becomes this, and this will become x plus 4. And then, what else do we have? I guess we can multiply through, get rid of the fraction, multiply through by 5, and that'll just give me 6x plus 1, and this will be 5x plus 20. So this will be 6x plus 6, so it'll be x minus 14, I believe, is 0. So x is 14. Yeah, I think so. So the perimeter up here we had figured out was 3x. So therefore the perimeter, 3x, is 3 times 14, which is 42. The function f has the following properties. Its domain is all real numbers. It is an odd function, that is f at minus x is equal to negative f at x, and f at 2x minus 3 minus 2, f at 3x minus 10 plus f at x minus 3 is equal to 28 minus 6x. Determine the value of f at 4. For this one, I think we have to do a little bit of trial and error. Because there's no function, like, you know what I mean? We don't know what f at x is. Is it linear? Is it quadratic? I have no idea. So the only thing we can do is just sub in values of x and see what happens. So for example, when x is 2, if we put that into this equation, we get f at 1 minus 2 f at negative 4, right? Plus f at negative 1, and that's 28 minus 12. So f at 1, this should have been f at negative 4. And then we use this property, so that'd be 2 times minus f at 4, and then this is minus f at 1, and this is 16. So this cancels with that, and this becomes 2f at 4 is 16, and therefore f at 4 is 8. And that's what they wanted. So, as you can see, the approach to this question is just substituting, or trying to substitute some value for x and seeing what happens. A right circular cone contains 2 spheres. As shown, the radius of the larger sphere is 2 times the radius of the smaller sphere. Each sphere is tangent to the other sphere and to the lateral surface of the cone. The larger sphere is tangent to the cone's circular base. Determine the fraction of the cone's volume that is not occupied by the 2 spheres. Well, we need to draw a pretty decent diagram here. So let me attempt to do that. And so here we go. So that cone, we've got a, oh boy, I've got to put in a couple circles here. There's 1, and then there's 2, and that's actually not so bad. Now I've got to label them. That's a tangent. That's a tangent. And then this I'm going to call 2r, 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 and this is r, 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 because the radius is 2 times for the smaller, if you compare the larger to the smaller. And then I'm going to draw a line from here to here. And these are right angles because tangents touch at right angles. So because tangents touch at right angles and the symmetry of this diagram, this will be the same as this. Yeah. So that I'll call big R as sort of the radius of the top. Like if you look at a bird's eye view, it would be like a circle. So that's the radius of the top. And therefore this is also R, because those two triangles are essentially the same. Yeah. Okay, and then I got to keep going here. I've got a little bit more labeling to do. The next one, I'm going to draw a line that's perpendicular, or parallel, I should say. So a line that's parallel like this, parallel to this. So if this is a right angle, this is a right angle like that. And that, I don't know. So I'm just going to label that length X. Yeah. That I don't know yet. Okay, but no problem. I can use Pythagoras. I can use Pythagoras on that triangle. Since from here to here is R, from here to here will be R, and then from here to here will be R, since the whole thing is 2R. So that means x squared plus r squared will be 2r squared, right, from that triangle. And therefore x squared is 3r squared, and therefore x is, hold on, did I do this right? Oh, sorry, it's 3r, sorry, 3r. So this is actually 9r squared minus r squared. So x squared is 8r squared, so x is 2 root 2r. Okay, so that's pretty decent. And then now I'm going to need to use similar triangles here, but I think I need to do a little bit more labeling here. Well, from here to here, x is 2 root 2r, so I can plug that in, 2 root 2r. So from here to here, that guy. And then, what else can I do here? Yeah, I got to use similar triangles, and I'll show you, I'll label those triangles in red. That triangle and this triangle are similar because they both have identical sort of angles. There's that right angle, and then there's this angle in here. That angle and this angle are the same. So therefore its dimensions would be the same. So let me label those dimensions. From here to here, therefore, from here to here will be 3r, which is the same as from here to here. And then this guy from here to here would be the same as this one, 2 root 2r. Okay. All right, I think I got it. So now we use similar triangles once again, but this time I'll draw them here. It might get a little confusing. The big one, well, that's r, and then this is the top from here to here, all the way from top to bottom. And just call that h. Then we'll call this theta. And that is going to be similar to this little guy here, the red one. This one here. This one right in there. So that little guy is similar. So we've got the same angle, you notice. So that's why those two are similar. And therefore, if I label the side, that was r, and this was 3r, and this was 2 root 2r. So that means, using similar triangles, that the big R over h is the equivalent of r over 2 root 2r. So that means that r is equal to h over 2 root 2, because the r's cancel. And the h, if you add up all the h from top to bottom, it's 2 plus 2 plus 1 plus 3. So it's 8r, actually. I believe that is true. 8r over 2 root 2. And then, therefore, this would be 2 root 2r. Yeah. It'd be 4 over root 2, and then when you rationalize the denominator. Okay, so that's pretty good. Now, that was just the setup of the question. Now, finally, we get to actually do the math, which is the final part of what they're actually asking, which is determine the fraction of the cone's volume that is not occupied by the two spheres. So basically what that means is you want the full cone, which is pi r squared h times 1/3, and minus from it the two spheres. So the first sphere is 4/3 pi r cubed, the smaller sphere, and then minus from that the biggest sphere, which is 4/3 pi 2r cubed. And then, of course, you divide by the cone, because we want a fraction. So pi r squared h. And then the good news is we can substitute in all our findings to eventually get rid of all the variables. Okay, so the first thing, we get rid of all the pi's, I believe. All the pi's cancel. This guy, that, and that. And then I think we can substitute immediately for r squared. R squared would be 8r squared, I believe, right? Because if you square both sides, it'll be 4 times 2, 8r squared. So this r squared, we can put 8r squared. And the h, we know, was 8r. So 8r. And then we have 4 over 3 r cubed minus 4 over 3, 8r cubed. And over this guy, which is 1 over 3, well, it's the same as here, so it's 8r squared times 8r. Okay, hopefully I did that right. So now this is 64 over 3r cubed minus 4 over 3r cubed minus 32 over 3r cubed, all over 64 over 3r cubed. So the top one is what, 60 minus 28? Yeah, 28 over 3 r cubed over 64 over 3 r cubed. Now the r cubes cancel, so we just get 20 over 3, invert and multiply. So this is 28 over 64, so 14 over 32, which is 7 over 16. 7 over 16 is the fraction that they are looking for. Let a be a fixed number. Define m at t to be the maximum value of minus x squared plus 2ax plus a over all real numbers x with x less than or equal to t. Determine a polynomial expression in terms of a that is equal to m a minus 1 plus m a plus 2 for every real number a. Okay. I think we have to change this into a format, because if you have a polynomial or quadratic, we can figure out the vertex hk. So, but that can only be found if we put it in this form, x minus h squared plus k. So we've got to convert it. So m at t, they're saying, is the max of minus x squared plus 2ax plus a. Okay, so we've got to convert this guy into this form. Okay, not a problem. First, let me factor out the x, the negative, I should say. And then that gives me this. We have to complete the square. So you guys remember how to complete the square, right? You take that coefficient, which is minus 2a, take half of it, which is minus a, and then square it. And then what you do is you add that and then subtract it. And what that does is allows you to factor those three. Hold on, that shouldn't be there. So then that negative, and this would be x minus a, I believe. And then don't forget, when you kick that out, we've got to multiply by that negative, so this becomes positive a squared plus a. So there we go. We got it in that formula, format. So that basically means that if you've got some parabola, that when this x value is a, it achieves a maximum y value, and that would be a squared plus a. So that is the sort of the interpretation of that. So now we move to the next part, now that we've got that, is this m at a minus 1 plus m at a plus 2. Now, I'd like to insert some graphs here to kind of help understand how to figure this out, because without the graphs it might be a little bit difficult. These are the graphs, so let's talk about these because these are important. In the first one, if you notice, when t is less than a, so this a comes down, this is a, and this is the t right there. When t is less than a, the maximum will be f at t. So in this case, it's this whatever, because t is less than a. So you got to put in t into the function, and that will give you the maximum. But when t is greater than a, so in this scenario, the maximum is this guy, because f at t is here, and as you can see, and therefore the maximum would be f at a, and that's the interpretation of this sentence. This sentence might not be that clear. The first sentence, that define m at t to be the maximum value of that expression over all real numbers where x is less than or equal to t. So the interpretation of that is this. That means this right here, that if t is less than a, the maximum will be f at t. If t is greater than or equal to a, the maximum will be f at a. So therefore, m at a minus 1, it would be f at a minus 1, and m at a plus 2 would be f at a. Since a minus 1 is less than a, it's in this category, and a plus 2 is greater than a, which is in that category. So that is the interpretation. It's a little bit tricky, but it's not so bad. So therefore, moving back to this guy, this m at a minus 1 plus m at a plus 2, that's basically going to be f at a minus 1 plus f at a. And that's because this a minus 1 is less than a, and then this a plus 2 was greater than a. So we just have to substitute it into this one. So minus a minus 1 minus a squared plus a squared plus a plus minus a minus a squared plus a squared plus a. Okay, when you simplify this, this becomes minus 1 squared plus a squared plus a squared plus a. And this looks to me like 2a squared plus 2a plus, hold on. Let me see if I did this right. Minus 1. Yeah, minus 1. So this is the final simplified expression that they're looking for. The graphs y is equal to 2 cos 3x plus 1 and y is equal to minus cos 2x intersect at many points. Two of these points, P and Q, have coordinates between 17 pi over 4 and 21 pi over 4. The line through PQ intersects the x-axis at B and y-axis at A. If O is the origin, what is the area of triangle BOA? Now I have no idea what this looks like, so I'm just going to guess and make a little graph. So the first, I don't know, so I'm just going to make a little estimation as to what it might look like. Something like this, let's say. And the second one, again, I don't know, so I'm just going to say it's something like this. I'm not sure. But one thing is for sure, that at least I got some intersection points, right? I got this intersection point, that intersection point. So the first intersection point I'll call P, and the second intersection point I'll call B. And I don't even think I drew this properly, but I'm just trying to illustrate what oh, no, sorry, the second intersection point is called Q. And then they're saying there's this A and a B, right? The line through PQ intersects the x-axis at B. Okay, so first I got to draw a line here. All right, so I've got to draw a line between P and Q, right? The line through P and Q. Oh boy. Okay, let's see. Okay, so I sort of made an attempt to draw that line PQ, right? Where that's P and that's Q. And then I just want to label the A and the B. So the B is where it intersects the x-axis. So this would be the approximate B, that little guy right there. And the A is where it intersects the y-axis. So that's A. So they want you to figure out the area of triangle BOA. So B, where O is the origin. So BOA. And you guys get the triangle. Okay. I think I understand. I just want to set it up. And then we can kind of proceed. All right. So the first thing, of course, is we have to find the intersection points. And therefore, to find the intersection points, we have to set those two equal to each other. So 2 cos 3x plus 1 is equal to minus cos 2x. Great. And I'm going to simplify this for time's sake and just sort of insert the whole algebra. Oh, there you go. There's all the fun that you have to go through. Well, you have to use some identities, I think, and then you'll be able to figure this out. And at the end, you get this thing that basically says that cos x times cos x plus 1 times 4 cos x minus 3 all equals 0. So from that, you can deduce that either cos x is 0 or cos x is equal to negative 1, or that cos x is equal to 3 over 4. Now, they're telling you that the points P and Q are between these two guys. So 17 pi over 4, which is 4.25 pi, I believe. This makes it a little easier. And between what's the other one? 21 pi over 4, which is 5.25 pi. So the P and Q are between that. Okay. So we've got to figure out what P and Q are. If I have done this properly. See, I don't know what the graph looked like, so I just kind of, guessed. But that's okay. I think I can figure this out. With these, this is very helpful here. And you guys remember the graph of cos x, so it shouldn't be that hard with the little, or even your calculator, but if you remember the graph of cos x, it kind of, undulates like this. Let me draw the graph of cos x a little bit better. So it's going to start like that. It's going to go like this, right? Yeah, like that. So this obviously is the x-axis, and this is 0. When it's 0, cos x up here is 0. What I meant to say is that when x is 0, cos of x is 1. And when x is 90, so that's pi over 2. That's pi over 2. It's 0, and this is pi, I believe. Yeah. And then so on like that. So we want it to be between 4.25 pi and 5.25 pi. So if, for example, now we got to use some numbers. If we had 4.5 pi, cos of 4.5 pi would be equal to 0. Okay, so that satisfies this guy. And then if we have 5 pi, the cos of 5 pi is negative 1, and that satisfies this. So since these two values are between this and this, which is what the question is saying, we can use those two values, this guy and this guy, as my P and Q. Yeah. Now they don't actually tell me where's P and where's Q. So it doesn't really matter, I guess. I had put P before Q, but I don't think it really matters if P is before Q or Q is before P. This is my P and this is my Q. All right, so so the P therefore would be 4.5 pi and negative 1, and my Q would be 5 pi. Oh, sorry. To get the y coordinate, I've got to sub it back into one of these original equations, either this guy or this guy. Yeah, so let's just use this one. Y equals minus cos 2x. So y equals minus cos 2x. So when we have 9 pi, right? So this is going to be 1. So this will be 4.51. And then q would be, well, q I've designated as 5 pi. So y is equal to minus cos 10 pi. And therefore that would be minus 1. Okay, so there we go. Finally, we got the 2 points. And then now, finally, we can create the equation of the line, and then we can figure out where the line crosses the x and y axis, and that will give me points A and B, and then I can solve for the area of the triangle. Okay, so now we just have to create the equation of that line. Equation of line. So just use the formula for equation of a line. And then the slope. Slope is going to be 1 minus 1, rise over run, right? So 4.5 minus 5 pi's. So that's going to be 2 over minus pi over 2. And that's minus 4 over pi. Minus 4 over pi. And then x minus 5 pi. And then when you simplify this, this becomes y is equal to minus 4 over pi x plus 19. Okay, x and y coordinates. So this is the line. This is the line. This is A and B, right? According to how I labeled it. Yeah, so not so bad. Probably not perfect, but not so bad. When x is 0, y is 19. Well, hold on. When x is 0, y is 19. And when y is 0, x is 19 pi over 4. So the area of that triangle, AOB, area is 1/2 base times 7. So the base is 19 pi over 4. The height is 19. So that's going to be 361 pi over 8. There are 16 distinct points on a circle. Determine the number of different ways to draw 8 non-intersecting line segments connecting pairs of points so that each of the 16 points is connected to exactly one other point. All right, so let's do a little bit of a let's figure this out one step at a time. Let's say you just had 2 points. Then what would be the number of ways of doing this? Just one. So when you have 2 points, I'm just trying to create a little bit of a formula. How about you have 4 points? You have 1, 2, 3, 4. There's this way, and then there's this way, and then that's it. Because it's non-intersecting. That's the key thing here. They can't intersect. So when f at 4 is the points, there's only 2 ways of doing it. And then 6, they actually gave me in the question, that's equal to 5. Yeah. So in general, f at 2n, since we are just calculating the multiples of 2, is actually given by the formula f at 2n minus 2 plus f at 2 times f at 2n minus 4 plus f at 4 times f at 2n minus 6 plus f at 6 times f at 2n minus 8 plus dot 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 all the way till f at 2n minus 4 times f at 2 plus f at 2n minus 2. So you use the recursive formula to keep figuring out f at 8 and then f at 16, which is what they want, right? They want to figure out, 16 distinct points. So I'll substitute in the math. So we've got So this is the first calculation for f at 8 using that formula. And then you would then figure out f at 10, basically all the two ends, f at 12, f at 14, and f at 16, which would eventually give you 1430.